Welcome to today's webinar, Unmanned Aircraft Navigation, brought to you by GPS World and Platinum sponsor, Hemisphere. I'm Diane Safranek from North Coast Media, publisher of GPS World magazine, and I will be your event manager. Before we get started, I want to let you know that today's webinar will be recorded. You are currently in a listen-only mode. The recording will be available 2 weeks from today on our website, gpsworld.com/webinars. A link to the on-demand recording will also be emailed to you when it is available. At this time, I'd like to acquaint you with the ways in which you can participate during today's presentation. Please notice the Submit button in the lower left-hand corner of your console. We encourage you to ask questions throughout the presentation. Just type in the text box at the bottom left, then click Submit to place your question in queue. Questions that were submitted during registration may be covered in this webinar. Some questions may also be answered in an upcoming issue of GPS World magazine or in one of our e-newsletters. We strive to answer as many of your questions as possible. Finally, if you experience any technical difficulties during today's event, select Help to submit your issue, and assistant producer Bethany Chambers or I will personally assist you. Now I'd like to turn today's event over to our moderator, GPS World's Tony Murfin.
Thanks, Diane, and welcome everybody to our webinar on unmanned aircraft navigation. So I'm Tony Murfin, as Diane pointed out. I do the professional OEM newsletter, and we're going to discuss unmanned navigation, aircraft navigation. So unmanned navigation is a very important aspect of being able to use UES, and we have a number of industry experts with us today who are going to talk about what they do in that market and what type of products they're bringing to the marketplace. The FAA released a new roadmap for UAS integration into the national airspace on November 7th, and our panel may also be able to mention their views on this stuff. So I'd like to just introduce our experts. Olivier Casabianca is with Trimble. Eric Brewer is with Rockwell Collins. Neil Gerein is with NovAtel. Hal Adams from Accord Technology, and Howard Loewen from MicroPilot. And without further ado, I'd like to turn the stage over to Olivier.
Thank you, Tony. So good morning, good afternoon, or good evening, ladies and gentlemen. So my name is Olivier Casabianca, and I am the business area manager of the Trimble GNSS OEM portfolio. So before talking about the unmanned aircraft navigation, so just a quick background of what is this Trimble GNSS OEM business area. So Trimble is well known as a solution provider for the positioning industry, and the OEM division is here to provide our key customers and key integrators some product to integrate. To integrate it into their system. So our goal is really to be a leading provider of advanced positioning solution to help customers or integrators to develop their own system for their own application. And obviously, unmanned application is one of the targeted applications for our product. Obviously, the market served by our portfolio are for precise positioning, so that may go to surveying, machine control, agriculture, and so on, but also for unmanned vehicles, and we will see this after that, and also for vehicle guidance, which is also applicable for unmanned vehicles. Just try to pass the next slide. So here we go. So GNSS for unmanned system, unmanned vehicles. So we may split the needs in two parts. So first for navigation or autopilot, where we may have various needs of accuracy. For small UAV, most of the small UAV are using some autonomous accuracy and may use some consumer chip with 3 to 5 meters precision accuracy. But we see more and more demand for higher accuracy. These higher accuracy requirements are leading to the use of professional grade of GNSS component or receiver. But we may also use GNSS for the payload. So, and for the payload, we may use the same GNSS which is used for the navigation part. But I would say that more often and very often we have a different GNSS really targeting the customer application. So, and it could be for various reasons. So on various applications, it can go for high quality raw data for post-processing purpose, high accuracy requirement from DGPS, OmniStar, global positioning, or advanced positioning up to RTK and centimeter level of accuracy. Or really specific application like moving baseline RTK for relative positioning when you want to compute the relative vector between two moving points. And also up to heading and full attitude determination using GNSS only or GNSS plus IMU solution. So these are really the two components in UAV, UAS where you can use GNSS for navigation or for the payload. Now, just a quick overview of the Trimble product line. We are offering a broad range of OEM receiver as an OEM board or sensor from very various application and solutions. So, but what is really important is all these products are high-end receiver. It could be from single frequency up to multi-frequency, multi-GNSS receiver, so full coverage of GPS, GLONASS, Beidou, Galileo, and so on, from L1 only frequency up to L1, L2, and L5 frequency. We are providing the whole range of positioning solutions, so from standalone up to GPS, DGPS, OmniStar capable, or RTK. We are also providing some module with Ethernet, Wi-Fi, and 3G capabilities, so in a single module for integrators to put in their system. And for small UAV, it could be also a key point to integrate a standalone module with all GPS plus communication capability at the same time. And we are also providing some solution for precise heading and full attitude solution. Now, I would like to focus on first more on the payload part and some really advanced solution, advanced application with some example of moving baseline RTK or relative positioning. So we see more and more some demands of being able to provide some relative positioning between two moving platforms. So at the end, the real position is not so important, but what is important is the distance between these two moving platforms. So to know the delta X, Y, and Z between two vehicles, and to be able to monitor this vector very accurately at a centimeter level of precision. So, and what is it? This is an RTK solution, but exactly the same, but using the idea that the base is not a fixed base, but a moving base. So, but at the end, this is really high-end and advanced solution, including carrier phase measurements and ambiguity resolution to be able to provide this accurate vector. So, so you just need to have a data link between two moving solution with a suitable GNSS receiver to pass the information from one platform to the secondary platform, and you will be able to monitor the accurate vector between two moving platforms. So with such application, we may imagine a lot of a lot of applications like a swarm of moving UAVs. So you may have a primary vehicle with its own GNSS equipment, with its own navigation piece and with its own payload, and a fleet of UAVs around these primary vehicles. And the primary vehicles will be able to determine very accurately the precise vector between each of these UAVs and itself. So this is really the concept of a swarm application, as you can see on this slide. Another good example is a swarm of flying sensors. So there is no primary vehicles, but all flying sensors are capable to know where the other flying equipment are relative to itself. So with a piece of communication between all the UAVs and the suitable GNSS equipment, you will be able to have a swarm of flying sensors capable to know where everybody is around itself at a centimeter level of accuracy. So this kind of application could be also extremely useful for autonomous landing or docking. So you don't need to know where is the flying sensors or the UAVs when it comes to land to dock on a platform like it is on the pictures right now. But what is really important is to know very accurately the vector between the docking station and the UAV itself. So doing this, you may try to go to a full autonomous landing application. Exact same application for autonomous refueling. So you may have to know very accurately the distance between these two UAVs to be capable in the future to do some autonomous refueling for such unmanned aircraft system. So, but this is typically the application that could be used using the relative RTK or moving baseline RTK techniques. Another interesting application for some payload is to be able to provide some positioning plus full GNSS heading or attitude using GNSS only. We will see after that the use of GNSS plus IMU, but it's also possible with GNSS only using 2 antenna or 3 antenna system or even 4 antenna system. You are able to provide not only the position but the full attitude, including heading, pitch, and roll information in a very accurate way. So for those who are familiar with hydrography bathymetry with multi-beam echo sounder, this is exactly the same kind of application. So the payload on board such equipment needs to compensate platform movement. And to compensate platform movements, you need to know the position, but also the full attitude, heading, pitch, roll. And this is absolutely achievable with GNSS-only equipment. So with a 3 antenna system, you are capable to provide full attitude information. And then to do the same, you can also achieve this kind of application with GNSS plus inertial equipment. And within Trimble, there is a division well-known, Applanix, which is a leading provider of GNSS inertial equipment with a mix of high-end GNSS board coming from my division, plus specific firmware application on the IMU unit to provide a full range of application for GNSS denied environment, to provide full attitude information, or also to provide to be able to work in continuous positioning when GNSS only is not enough. So you may go to Applanix to discover their suite of products, but this is really some high-end technology using high-end GNSS receiver plus high-end IMU solution. now I will discuss a little bit more on the navigation part on the UAV. So on the navigation part, we of course, as said by Tony, so there is a lot of discussion about regulation and evolution that may impact UAV and US. So a roadmap has been released early November to talk about that, but the outcome are not known yet. But what may happen in the future is that for the avionic components for navigation solution, it may lead to the use of some FAA TSO qualified receiver, just as there are no for main aircraft. So and to use some certifiable equipment or receiver. Another example is ADS-B, which is a high-integrity avionic-rated GNSS receiver for radio transponder. And per FAA next generation modernization, all single aircraft will have to be equipped by an ADS-B receiver by 2020. And we may imagine that this will be applicable as well for UAV to be able to fly in the same airspace system. So with regards to this needs of certification, so in Trimble hashtag portfolio, we have one certifiable product which has been specifically designed for flight management system and for UAV application, which is FAA qualified and certifiable to meet RTCA DO178 level B. And this is a Skynav GG12W, and this product has been specifically designed for flight management system, but also for unmanned autonomous aircraft. So we already have customers integrating this product for UAV in advance with regard to the evolution of the regulation, knowing the possibility of this kind of requirement in the near future. So I think, Tony, I'm done. So thank you very much for attending this webinar. And Tony, this is yours. Thank you.
Thank you very much, Olivier. That was informative and lots of different applications there I saw. So just moving along, we're a little late in our schedule, but if Eric, you could go ahead and present.
Okay, thanks a lot, Tony. Yeah, my name's Eric Brewer. I'm a senior systems engineer at Rockwell Collins Control Technologies. So Rockwell Collins Control Technologies was originally a startup called Athena Technologies based in Warrenton, Virginia. And we specialized in autopilots for unmanned aircraft, mainly small unmanned aircraft, so think Shadow or Scan Eagle sized. And now we were acquired by Rockwell Collins in 2008, and since then we've become essentially a center of excellence for guidance, navigation, control, and estimation technologies within Rockwell Collins. So I began at Rockwell Collins in 2010, and one of the first programs that I worked on was the damage tolerance program. And so you'll see some pictures in the bottom right here where we took a small subscale F-18 and ejected more than 60% of the right wing and showed that we were still able to successfully recover the vehicle and perform automatic landing. So this was one of the first programs that I had an opportunity to work on. I'm going to give you a little bit of an overview of some of the products that we have at RCCT. Our Athena product line shown here are GPS-coupled inertial navigation systems, which also incorporate air data sensing and flight control computing all in one box. So we have various levels of inertial sensor performance here, so all the way from sub-tactical grade to navigation grade INS performance, as well as various levels of environmental qualifications. So we also have a triplex architecture shown here, which utilizes 3 of our 411 INS products. And those, in that configuration, the 411 is used for INS and GPS and air data only. And then our general purpose computer handles redundancy management as well as flight control computing. And so we're able to achieve a 1 × 7 per flight hour performance with this system. So this is mainly used for optionally piloted vehicles, which I'll talk a little bit more about later. Some of our mission processing products, as I mentioned, we have the GPC 1000, which is mainly used for autopilot and boating management. It has various I/O, including CAN, Ethernet, discrete, serial, pretty standard stuff. And then the GPC 2000, or ASIM, is mainly used for message routing and message translation. Can also be used as an Ethernet switch. And then for more processor-intense applications, we have our GPC 3000, or small mission computer. And this can fit up to 4 multi-core cards, expandable to 512 gigs per slot of storage. So there's quite a bit more computational capability for that box, and it weighs in at just under 12 pounds. So some GPS products that we work on, we have a SASM RTK system, which is used to enable the precision recovery of the on the Navy's small tactical UAS program. So you'll see here this particular vehicle is recovered by capturing its wing onto a vertical wire, and then the vehicle will be suspended on that wire after it is captured. And so to enable this, we use our real-time kinematic solution, which provides very precise position relative from the UAV to the skyhook wire, which is used to guide the vehicle to the wire. And so this is also used on a moving Navy ship. So we blend both inertials as well as the 3D RTK solution to provide a high accuracy relative solution that can be used to recover the vehicle. So the accuracy that we get with this is around 20 centimeters 3D relative position for baselines up to 30 kilometers. The STUAS platform is mainly used for intelligence, surveillance, and reconnaissance by the U.S. Navy. So they'll launch this off the back of the ship and basically go look around and get an eye in the sky in terms of seeing what some of the bad guys are up to. Another platform that we work on is the Aurora Centaur. So this is a general aviation certified airframe that Aurora Flight Sciences has converted into an optionally piloted vehicle. And what optionally piloted means is that you can have a pilot on board, or you can operate fully unmanned like a normal UAS. And so on this vehicle, we utilize our XXX Athena 411 configuration, and we have our own automatic takeoff and landing, which is based on a NovAtel-based RTK solution, and our relative navigation processing. So it's similar RelNav processing to what's used in the STUAS program, but for a non-SASM configuration. I'm going to talk a little bit now about some of the GPS hardening products that we have. So as you may know, there are several threats to GPS, including unintentional or intentional jamming, full system loss of GPS, or many other things. So a few mitigation strategies are to, 1, prevent losing GPS in the first place, or 2, to use other methods to navigate. So I'm going to talk a little bit about both of those. I'm actually going to skip that slide in the interest of time. So a few of our anti-jam products, what anti-jam products are used for is if a jamming signal is present, an anti-jam receiver can be used to mitigate the effects of this jammer. So you can essentially still keep lock on the satellites when you have a really high level of jamming. And so these are used both in airborne navigation as well as weapons. So you'll see our Digger receiver, which is used to enable autonomous landing of F-18s on aircraft carriers for the JPALS program. That's Joint Precision Approach and Landing. We also have the NavStrike, IGAS, NavStorm, and NavFire. Those are some other anti-jam receivers that we have available. Next, I'm going to talk about some ways to mitigate the loss of GPS. So in the case when GPS is no longer available, we have developed an image augmented INS software. And so the basic idea is you have inertials from a tactical grade INS. And so when I say tactical grade, I mean lower performance than a navigation grade quality that you might find on, say, a manned platform. And so the advantage of those is they're quite a bit cheaper. So what I have shown here is a plot of the feature points that were tracked by this image augmented INS software. So the basic idea is to have a camera pointing down on the ground and tracking feature points. So the gray dots are the feature points that were tracked on the ground. The blue is the output of our navigation grade 611 INS with GPS enabled. So this serves as the truth data source. And then our INS filter output is shown in green. So you can see after flying about 16 kilometers, the drift was less than a half a kilometer. So this achieves navigation grade performance with a tactical grade INS. And this can be a big deal for when GPS is lost and you need to maintain navigation performance within the the national airspace. So now I'm going to talk a little bit about looking ahead for unmanned aerial systems. So from our perspective, we see a reduced growth in the domestic military markets due to both pulling out of Iraq and Afghanistan and general fiscal uncertainty. And we also see a potential split in UAS development roadmaps, whereas one direction you'll have larger, higher reliability, higher complexity systems moving towards national airspace integration, and also another set which is significantly smaller and cheaper systems for flight outside of the national airspace. So the FAA has come up with their roadmap, and I think it's pretty clear there's a little bit of a gap between where the UAS technology is now and where it will need to be for full national airspace integration. Some key things there are data link integrity, sense and avoid. There's a whole list of them in the FAA's roadmap. Some other key hurdles, there are a lot of them, so this is only, of course, a small subset. One, as I mentioned, is an inherent reliance on GPS. So most UAS that operate now are highly reliant on GPS, and really right now there's nothing that can reach that level of accuracy. You can use inertials to stay pretty good, but in terms of knowing your position in an absolute frame, there's really no substitute for GPS. Also, evolving requirements. So it was pretty clear from the FAA's roadmap that there are a lot of things yet to be defined, and that means that to be able to have a system ready to meet those requirements will be quite a challenge, as they will be changing over the next few years. And also media scrutiny and just overall public perception, I think, are also key challenges. You'll see a few sensationalist headlines here that I was able to find. And I think the second one really kind of highlights some of the perceptions of the public on UAS. So you'll see that they mention it as a robot kill chopper. So what this was a Fire Scout UAV that went into Lost Link, and it did end up drifting into Washington, D.C.'s national airspace. This was a really big deal and got a lot of people excited. So I think to combat that, we really need to to just kind of keep people informed as to what UAS really are doing. I mean, they're not sentient beings, and actually the FAA typically does not want any non-deterministic behavior in a certified system. So the real purpose of a UAS is to provide services for us, so take humans out of dirty, dangerous, and difficult environments. And overall, I think once UAS are integrated into the NAS, we will be able to improve safety, efficiency, and reliability of the air traffic system. So that was all I had. I'm going to pass it back to Tony.
Okay, thanks a bunch, Eric. And just moving along quickly, we'll put Neil Gerein up.
Hello there. I'm with NovAtel Inc. in Calgary, Canada. I want to tell you a little bit today about what NovAtel does in the unmanned aircraft navigation and support area. NovAtel, we're a manufacturer and provider of precise positioning technology. And included in that is largely based our OEM product line, which is composed of the large number of the cards you see there in front of you. These are receiver cards that track GPS, GLONASS, Galileo, and Beidou signals, so all available in upcoming GNSS. And they're supplied to manufacturers and integrators like Eric had mentioned when they use NovAtel receivers inside their autopilot. So we provide the raw measurements to enable technologies like payload technologies and navigation. Going from the top on down, the three major ones we sell into the UAV market are the OEM 638, that's a triple frequency GNSS receiver, 240 channels, and it also includes L-band. L-band corrections are important for UAV use because that enables you to get differential corrections over on the same type of antenna that you'd have with a GPS L1 antenna and enable better navigation. The middle one, the OEM 628, also a triple frequency GNSS with L-band. And both this and the OEM 638 can be tied to external frequency inputs. They have a very robust interface, but also for UAV operations, they're available in high vibration TCXOs versions. What that allows you to do is sometimes on takeoff and landing out of a UAV, you have a high vibration environment, and you have to maintain GPS tracking throughout there. We also have at the bottom an OEM 615. That's a dual frequency GNSS, so GPS and GLONASS and Galileo L1, low power consumption for smaller platforms. So all these can be used for precision landing, but also an important aspect is not just the navigation, but the payload sensors. If you have an electro-optic or infrared ball on your UAV, you quite often need to know the position of that to get your targeting information, separate from having to get the information from your autopilot. And also because all these here units are civil units with multiple GNSS, it provides you a measure of protection against civil anti-spoofing, because you can always rely, instead of just on the GPS signal, you can also look at the other signals that are available like GLONASS, Galileo, and Beidou. But there is situations where you need to have full SASM RTK. For example, UAV use in theaters of operations. And for that we have the OEM 625S. This provides protection with a military SASM unit. This is a drop-in replacement in the same form factor as the OEM 628, but it also includes an L3 IEC X Factor 2 SASM. What we do is we can take the SASM measurements out of the X Factor 2 and put them into the NovAtel processing engine to give you 2 centimeter level RTK for precise capture of UAVs or precision landing. Also of note is something unique is the PPS with SPS fallback mode. If the keys need to be zeroized on a SASM receiver, or if the keys are lost, typically a SASM receiver will default back to meter level positioning. That can make it very hard to capture the UAV when it comes back for a shipboard capture or capture into a net or capture on a wire. And so what we do in this case is we fall back to the civil RTK as a backup mode, and that provides you access to the L2 civil signal and L2 semi-codeless. You're able to maintain your centimeter level accuracy. We also have what's called the line relative positioning and heading in a full military SASM mode on this for allowing military measurements with heading. We'll be adding our span INS functionality in 2014, and this has been security approved for operational use by the U.S. forces. The Align real-time heading is available on all those receivers, and it allows to have a heading solution using GPS only with either 2 or more antennas. So for example, Align heading is used lots on rotary ring aircraft where you need to know the heading very precisely in hover situations, and it's also used for precise capture into nets and other systems. For example, precise capture into nets, you need to know the orientation of the vehicle coming in as well as the orientation of the net. Align relative positioning can provide, extend it out to provide the 3D vector for things like landing capture onto moving platforms as well as in-air refueling and formation flying. You can go a step further by adding in the inertial measurement units. So all those receiver cards in the first slide are capable of running our span engine, which provides a tightly coupled GNSS and IMU, our inertial navigation system, combined solution. Availability at the card level or the enclosure level. UAVs, this is used on a lot of times on the sensor balls or on the payload, provide intelligence, surveillance, target acquisition, reconnaissance. Used for airborne mappings and also for shipboard landings. For shipboard landings, you can look at our website. I have a web link there to see an example of the Boeing Little Bird helicopter doing an autonomous landing at sea on a moving platform. Of note here is both cases we use inertial measurement units on the unmanned platform as well as on the moving ship. This allows us to give not only a relative vector for positioning, but also relative pitch, roll, and yaw, because the deck is not a stationary deck, it's moving along with the ocean. You can find information and videos at that web link. As GPS, if it's used as the main mode of navigation, which it almost entirely is in UAVs, there is the increased resilience on it and an increased worry about not having GPS due to jamming, whether intentional or unintentional. We've expanded our gadget anti-jam product line to include something called the Gadget AE. This is a small 4-element set of antenna electronics that can be hooked up to a variety of 4-element controlled reception pattern antennas. This allows you to detect where the interference is coming from and create nulls in the direction of the jammers to protect your GPS and make sure you can have continuous navigation so that you can continue on with your mission and also recapture your vehicle. Finally, there's the Waypoint software. Besides the flying of the UAVs, you also use UAVs largely for the payload that's on them. And a lot of times you need to post-process that data. For example, airborne mapping. You want to make sure you know the position and orientation of your camera. But if you do the post-processing of the data, you can do processing both in the forward and reverse positions and fill in any data gaps. For that, we have our Waypoint software group. We have GraphNav, which provides GNSS post-processing, as well as Inertial Explorer, which allows post-processing of GPS and INS, both loosely and tightly coupled data. A few of my own personal opinions on the FAA certification plans that Tony talked about before and the FAA roadmap. We see UAV growth is largely due to the affordability and the ease of use. Now that we move into the national airspace, that growth is going to be driven even further into other areas like precision farming and mapping of civilian airspace and many other applications. Equipment suppliers are going to have to work very closely with the FAA to ensure that this level of certification is appropriate first and foremost for the safety of the public, but we also need to make sure that the equipment is not over-certified such that it becomes unaffordable, and we must remain practical so that the industry is not stifled. So those are my opinions and an overview of the NovAtel products. I'd like to pass it back over to Tony.
Okay, Hal, you're next.
Okay, thank you very much. Let's get this up. Yeah, I'm Hal Adams, and Chief Operating Officer to Core Technology, which probably most of you have never heard of. And I'll give you a real quick rundown on that, and I know our time's pressed. We're basically a civil GPS developer, supplier, etc., and that's predominantly our focus. And it's a joint venture between Accord Software and Systems out of Bangalore, who've been in the GNSS business since 1991, and my company here in Phoenix, Accord Technology. We've actually been around in one shape or another since 2006, and we have offices in London, Melbourne, Bangalore, and Tel Aviv. And the primary GNSS research and development site, I have about 50, 60 engineers working for me in Bangalore. Just to give you kind of a background where we're at. We do have world-class aviation GNSS solutions, as I say, focused on civil, and we've basically been certified, first people to certify under the new TSO 145B and then C, and we are also the only supplier that actually provides certified or conformed, in the case of CCAs, to FAA standards modules. We're fully compliant to the U.S. FAA ADS-B 2165A for GPS source, and thus that being the most stringent requirement in the world, we basically meet all the other ADS-B requirements in the world. And as I say, we're ADS-B source compliant solution. We're being integrated onto a lot of airframes, manned and unmanned, by the way. And of course, that's the focus of our talk here today. Just to give you a little insight into the specific product that resolves the GPS source approval that meets fully FAA requirements. It's not a very big, expensive, or powerful GPS. And this is already flying. It's already certified in the U.S. on manned platforms. It's very small, size of a credit card, low power consumption, 45 grams in weight. So when we designed this point solution for ADS-B, we specifically had also thought about the unmanned environment, because they will probably likely have to meet the same type of rules which everybody's been talking about, which brings me around to our view on the take on the unmanned systems. And it's basically FAA-centric, because FAA seems to be the most active. They're working very closely with the EU and other areas, but they're kind of the hard guys to satisfy. And if you can do that, I think you're going to be fine. So we see this as a big market. And as we see it from our kind of GPS-centric point of view, the sense and avoid and the detect and avoid standpoint. And the analog is that if the unmanned aircraft will have to be as capable and safe in the airspace as manned aircraft, let's discuss a little bit about what that means. And first of all, the critical integration issues per the FAA is that there is a lack of regulation. The privacy thing, which is, of course, probably going to be resolved somewhere else in policy. Of course, the operational and system maturities, training for the military people who be operating them, let alone the civil, and risk mitigation of putting these UASs into the same airspace as manned aircraft, and a lack of sense and avoid solutions that are approved and recognizable will work. And of course, then the oversight requirements, which we have to suffer with in the manned aircraft, will be put in the unmanned as well. And everybody's referred to this roadmap. A couple of things I'd like to point out in the FAA roadmap just came out is the near term equals segregation of manned and unmanned aircraft. That's not going to change, of course, until a lot of things change. They've tried to streamline the COAs, and that seems to be helping. But one thing you should bear in mind is little subtleties in this roadmap, and it says that the UASs must, the procedures that address the critical issues, you see it highlighted in red there, must be compatible with next-gen operations. And that then would assume that it has to be compliant with the Advisory Circular 2165 for GPS source, and that's used primarily for the sense and avoid detect, ground-based sense and detect, and airborne, as you see there. I won't read through it. In any case, it appears that the GPS GNSS position source is a key technology to at least trying to keep the two platforms separated, just like we do in manned flight. So if you take that into account, and that's where we primarily focus our GPS effort, is the ADS-B, Automatic Dependent Surveillance Broadcast, and it's basically precise location, and not just precise location, but high degree of integrity that you are where you say you are, because those things will be retransmitted through the air traffic control system, and understandably you would want to make sure that the targets that are being retransmitted through the FAA ATC system are indeed where they say they are. And so that leads the FAA to this high integrity for the GPS source and the Rule 2165, which is predominantly for safe separation. Secondary is the NAS and management flow and the economics associated with putting economic flow to the air traffic. Now on the unmanned side, or the manned side, so as say the corollary to probably flow over to the UAS, it is an airspace rule, not an equipment rule. It's based on performance. And there's two ways to transmit your positions, Mode S and UAT 978 megahertz, and both of those go into the AT system. That little chart you probably can't begin to read, but it's available on the FAA website, describes what airspaces need what equipment, because you do not have to have ADS-B in some airspaces. But that's the basic way the works for the manned aircraft. And the key thing about GPS is a Q&A there at the bottom, and it says, must I use GPS? And the FAA's answer is, to meet the rule, which is 91.227, is that GPS is currently the only available positioning source known to meet all the requirements defined in the ADS-B rule out. And that applies to manned aircraft. Highly likely it will apply to unmanned aircraft. And based on our working relationship with the FAA, they keep repeating the statement that the UASs must be as safe as manned aircraft, including the systems. And that means they'll have to comply with the next-gen rules, and that means ADS-B sourcing. Some key contacts that you might want to follow up with to ask questions, I've listed them there. I won't go into it. But those seem to be the key players that we run into all the time at the FAA. And then lastly, to wrap this up, our GPS is a point solution for ADS-B, which is going to be required for both manned and unmanned. It's not questioned. And we do it affordably and meet the world requirements, not just the U.S. FAA-centric rules, and support that, as well as we have other engines that support LPV, which is a very precise GPS approach. And we also offer that in not only an LRU, or line replaceable unit, end unit, a sensor unit, but we do also provide circuit card assemblies, and we are providing those to customers today. And we also do license production. I guess and also we are actually on UASs already. We're on the Piaggio Hammerhead and being integrated to several other unmanned systems around the world. So the point is the market's large if the manned and unmanned mix can be safe, and I think that's predominantly our viewpoint. So, Tony, back to you.
Yeah, Hal, thank you very much for that. Some good pointers, especially on where the market is going. And I got to apologize. I made a lovely introduction for you, but I was on mute. But I'm not on mute now, and I've got Howard up next.
Thank you very much, Tony. My name is Howard Loewen. I'm the president and founder of MicroPilot. We're an autopilot, a UAV autopilot company, and we're based in Winnipeg, Canada. We've been around for almost 20 years, and we focus primarily on the civilian UAV market. We make our autopilots rely very heavily on the global positioning system, and we have customers that use a wide variety of different global positioning system solutions, from the consumer grade for the smaller kind of consumer grade professional UAVs for surveying and navigation to kind of carrier phase or moving baseline GPS receivers. We also have a triple redundant autopilot, and that uses both carrier phase GPS receiver and the consumer grade GPS receiver. And so some of the applications for the moving baseline GPS receiver, what you see here is a hover mast from a company called Sky Sapiens out of Israel. And basically what it does is it hovers over a moving truck. So it takes off from the truck, goes up maybe 100 feet, and then sends video systems back to the truck. And it has to follow the truck as it drives. And that's quite an interesting application of a moving baseline GPS solution. Some of the challenges we see to the UAV industry as we move forward, specifically the civilian UAV industry. First is a lack of good RF frequency allocation. There is no kind of worldwide frequency range allocated to GPS. We see some challenges with privacy, but they're relatively easy to resolve. And actually, privacy is probably the best thing that has ever happened to UAVs because it's got everybody talking about us. We think there's some moderate security issues that also need to be addressed. Especially for small UAVs, they really need to find something useful to do. Almost everything you can do with a UAV can also be done with a manned aircraft, and so you can look for future uses by what people are doing in manned aircraft. Regulations are, again, a bit of a challenge, and we speak a lot about that here. Primarily the parts that are the most difficult are the C and B seen, and the software certification standards. A lot of the software certification standards are designed for situations where if the software fails, there are definitely fatalities, whereas the automotive industry probably represents a better model in terms of if the software fails, you have some serious concerns, but there's not necessarily going to be fatalities. There's also a lot of indirect competition for UAVs. Everybody, when they're talking about UAVs, forgets that there's also a bunch of Cessnas flying around in the airspace, and any payload a UAV can carry, Cessna can also carry. And if you look at a lot of the characteristics of both UAVs and light aircraft, they're actually, if you had a choice, you'd probably put your payload in a Cessna rather than a small UAV. And so some of the things, you can, UAVs, small ones tend to have relatively short lifetimes, whereas, the standard aircraft last many, many years. And the level of training, while it's higher for a Cessna, you can find pilots everywhere. The cost of trained operators for UAVs, they're hard to find, so they're expensive. The cost for pilots, especially if they're building hours towards their airline transport rating, is quite low. Spare parts are everywhere for small aircraft. They're very hard to find for small UAVs. If you had a $1 million payload, you probably wouldn't have any worry putting it in a Cessna, but to put it in a UAV, you might want to hesitate. So I think, especially in the civilian market, UAVs have quite a long way to go. Sorry, and I forgot to push my next button. But we do believe that UAVs have a bright future. We're we're making a number of upgrades to our product line in order to prepare for the day when there are good certification standards that we can follow. We have a product called our trueHWIL in the Loop simulator, and what that does is we strip all the sensors off an autopilot, and we electrically simulate the sensor signals into the autopilot. And this gives the best quality simulation you can achieve, and is going to be a very important tool for certifying software on in your UAV. Another tool that we've introduced recently is called Extender Validate, and it's a validation tool. The configuring the options in a typical UAV is very, very complicated, and because everybody wants to do something slightly different. And so basically what it does is it takes requirements and allows you to link those requirements to setting in either the autopilot or the ground control station, and then link in validation data to show that your system is performing the way you intend it to do. observations about the present and the future. After looking at the FAA roadmap, it is a little bit vague. It would have been nice if it had been a little bit more clear. We're expecting that the FAA test sites will be delayed quite a bit. We're expecting that the standards to emerge more from the European Union. JARAS recently introduced a certification specification for helicopter UAVs, and helicopters are the most demanding of all types of UAVs from a safety standpoint, because you've got all these rotating, whirling blades, and so it's quite a good standard. And the EU is flying. You can fly a UAV commercially in the EU right now, and so we think that's going to be where the standards emerge from. We do think that the UAVs are going to become more popular in emerging markets where the regulations haven't been invented yet, and there are not so many Cessnas. The FAA, especially in the small UAS, unless they come up with rules soon, and they're quite reasonable, I think they're going to lose control of that market. Predator-sized UAVs, hard to see a strong commercial reason for them. Anything that can be done again with a small UAV can also be done with a manned aircraft, and Predator-sized UAVs are just very, very complicated. And we're been used by about 850 different organizations in over 70 countries, and this is a very fascinating industry to be in, and I think it has a very interesting future, and the next couple of years are going to be quite exciting. Thank you very much, Tony.
Well, thanks, Howard. So we've been picking up a whole bunch of questions as the presentation's gone forward, and we also had about 17, 18 before we got going. So we've probably got a little time to address a couple. And then what we're going to do is we're going to publish the results on the GPS website. And I'm pretty close to being able to do that for the questions that we already had. We'll have to do a bit of work on the ones that have come in. So let's look at a question here that says, could GPS be a standalone sensor for navigation, and what is GNSS coverage above 80 north-south parallel? So Olivier volunteered a tool that will tell you what coverage is in a particular location. And then Hal found some information on challenges for GNSS in the Arctic. Hal, could you mention what you found there?
Yes, I think of the website. I probably just Googled the right thing and came up. But basically, what's happening, and I was at the ground-based augmentation system session in Seattle for about a week in the summer, and a lot of presentations made by entities doing a lot of research, and we find out that there are not only scintillation issues with GPS signal at the equator, but we have issues in the polar region as well, which is a bit of a surprise to everybody, I think, and maybe not to some people. So there are some issues that degrade the operation of GPS, or I should say GNSS systems at those north and south latitudes. And I know from the ground-based augmentation system, which is affected very seriously by them, that there's a lot of work going on. So that's a cross-fertilization that'll help probably expand the effectiveness of GNSS in those latitudes. But anybody else have anything else to add?
So this is Olivier speaking. So just you can find on Trimble website a free tool that a GNSS mission planning in a way, so that will allow you to see the exact coverage on a specific point. So you may put a position somewhere on the world above 80 if you want, 80 degrees of latitude. And you will be able to see what is the exact constellation using GPS only, GPS plus GLONASS, GPS plus GLONASS plus Beidou. And you will see the benefit of adding constellation. You will see the various DOP available at a specific date and time. So this is an easy tool to have an idea of the coverage of the GNSS at any point of the world, anytime, on any constellation. So this is available on Trimble website.
Thanks, Olivier. Thanks, Hal. Another question I've got here is, what is the best technology to pursue as a backup to GPS? Quite a key question. And an answer I have is that GPS and inertial is the way to go, but only when GNSS is in denied environments. And then for manned aircraft, of course, you could lose stuff because you've got a breakdown in the aircraft. So procedures are the method of maintaining manned aircraft separation and clear airspace. And similar things will have to happen for UES. And there's a lot of work going on into research, magnetometers, deduced reckoning, etc. Anybody like to comment? Just jump in. Just looking for ideas on backup for GNSS failures.
Okay, so this is Olivier speaking. So as it was displayed in various slides in this presentation, so GNSS plus IMU is a way to back up GNSS or GPS failure. So time to time. So with hybridization between GNSS data and IMU data, you are able to provide more than position only, but position plus full latitude, but you are also capable to provide continuous positioning in case of GPS outage or GPS failure. So it's not a perfect one, so it will not work forever, but this is a way to augment the GPS information.
Okay. Probably a couple more. There's an interesting question which showed up late, which is which industries will see the greatest increase in usage of unmanned systems once the FAA opens up regulations for integrating unmanned air vehicles into society? Now that seems to me to be a regulator who might have asked that question, but as somebody responded, probably that application hasn't been invented yet. The point is that the applications are multiple and multifold across all segments. There's a lot of high precision surveying being done. There's a lot of pipeline inspection. There's an awful lot of applications which are underway right now, but they're just touching the edge of the iceberg, the tip of the iceberg. Anybody have any views?
Tony, Hal Adams here. I think you hit it very precisely in that if you think about where GPS was in the late 80s and what it was envisioned to be and what it's ended up being, and it continues to evolve, I mean, that's been probably a good analog to look at the UAS market as in, yes, we know what you could use it for today, but somebody probably hasn't even thought of the use you're going to use it for tomorrow. So once it's like capacity drives demand, once it's there and you have the airspace rules and you're able to use it, people are going to start thinking, hopefully, and that'll expand the use for that.
Yeah, exactly. Let's just try and pick one out of the... here's one for Neil. Is Gadget AE compatible with RTK?
Hi. We have done some initial testing and presented some results at ION PNT conference back in June of 2013 discussing gadget and some RTK performance. So I can refer the person who posed that question to that. Basically, it depends on the antenna that's being used and the phase center stability of the antenna. Where the RTK performance is in danger of breaking down is in heavy jamming conditions if the vehicle, there's lots of motion or lots of motion of the jammer, because that'll move around your RTK phase center. But the RTK can fall back from a 2 centimeter fixed solution to a float solution, or you can fall back to DGPS in those type of cases. So it all depends on largely on what the antenna that you have coupled with Gadget AE.
Hope that nailed that question. Here's another one. Could you define the NAS? That's basically the National Airspace System in the U.S. It's the where the FAA operates aircraft across CONUS. Hal, anything to add to that?
No, I think that's pretty precisely. It's wherever the FAA wants to ensure the safe transition and operation of aerial vehicles, no matter what their size, shape, or form takes. So you're right.
Right. There's one here for Olivier. On your slide 12 and 13, you show a mesh network among UAVs. Is this direct machine-to-machine network between air vehicles or between their ground station? What radio set supports this data exchange?
So in fact, it could be both. So it's possible directly between vehicles. So using various ways. So one could be some UHF radio link, data link. So it will depend also of the distance between the aircraft or the unmanned aircraft. But it's possible, so using some UHF link, for example, or it's also possible using GPRS 3G data link. So everything is possible. So
okay. All right. Well, it looks like we're hitting the time stop, so I'm going to have to wrap up the webinar. The slide that you all see is everybody's email addresses. If you want to make sure it gets to somebody, you email it to myself, and I'll chase people. But as I said, we'll put the questions up on the website as soon as we can with answers, and the webinar webcast slides will be up on the website within the next week or so. Diane, if you wanted to close us down, that's okay.
Thank you, Tony. And thank you, everyone, for attending today's webinar. An on-demand recording will be emailed to you 2 weeks from today. Please join us for our upcoming webinar, Detect and Locate GPS Jamming, on December 5th. To learn more, visit gpsworld.com/webinars. We look forward to seeing you there.